Hello guys, myself Amish. So here today we are gonna be talking about stationarity, how stationarity is important in particular data set, and from which model we need stationarity over there. So first I will explain you what is stationarity, right? So for stationarity, first of all, stationarity concept is only for time series data, right? If any time series has, like, for example, I will show you stationarity data set and non-stationarity data set as well. So first, for example, if this is our time, right? And if data set is like and the trend is downwards or upwards, so we can see there is no stationarity. The basic meaning of stationarity is all the fluctuations are around the constant mean or variance, right? For example, if I will show you the stationarity data set, you can see like this is the constant mean and variance. So all these fluctuations are around the mean and variance. So we can see this is called stationarity data set, and not this one and not this one, upward trends as well, right? This one is also a non-stationarity data set, right? So why stationarity is important? For example, if we give any model to predict or forecast any kind of amounts, for example, if this is 1 year time period, right? And if we give model to forecast for next 2 months, so a model only get to know it's downwards. So it is only going to give us the result downwards. But in this fluctuation, model can do the calculation and he can get to know why there is high and why there is down, right? So we'll get better results of stationarity and we get better forecast in stationarity. For example, in VAR model, stationarity is needed. So to find out whether the data set has stationarity element in it or not, there are 3 tests. Like the first is ADF. It's called Ed Fuller, or we can say sorry, I couldn't remember. Like I remember, but I can't recall it now. The Dickey Fuller test, right? So it's ADF, and there is also KPSS method, and there is also PP test. So we are going to run today ADF and PP test on Python and R. I'll show you quickly how to do it on Python first, and then I'll move further with R like this. So can you see, this is my screen? This is Colab notebook. This is online. Everyone can have access to this one. It's free and it's very fast. You don't need to download it because it is running on the server. So your computer will not get a load of Python, right? So first I have created new document, right? And I'll just rename this stationarity check, right? And first, before we start our project, we first need to upload our files. So in this one, see, this is my file. I'll just upload our data set, which is Amazon data that we had in last week, right? Okay. So now we have uploaded our data set. So for why Python is best, why I like Python is like there are all the libraries are integrated. We just need to use those libraries and we just get the result. For example, I will show you which libraries we are gonna using. First, we are gonna be using Pandas. So this is how we can import Pandas. So the library name is Pandas, and AS is aliases. So we can all run from PD, right? Sorry, it's PD, and we are also going to be needed Numpy. Numpy is for arrays and calculation, right? NP. We are also going to be needed Matplotlib, which is library to make visuals, make different charts, right? So why do we need to use this Matplotlib? It's because we get better idea whether data is stationary or not. Because first element is, we can have an overall look at the data, how the trend is there. Then we can directly get to know whether data is stationarity or not. But still we will run further calculations to exactly get to know why data is not stationarity in there, why there is no stationarity in data set, right? Import matplotlib.pyplot as.
And where is the list of those libraries? Like, is there like any source where you can
So
see?
yeah, for example, these all libraries are very famous, right? These all libraries are open source and it's created. For example, if you run Python library for data cleaning, so it will suggest you, but these are popular libraries, right? To become a data analyst or anything, These are the basic libraries that you need to learn. See, in this article we will go Python data clean libraries, some of them such as Pandas and Numpys. So Numpys and Pandas, these are the basic libraries. If you want to learn Python, Pandas, Seaborn, Numpy, and also Matplotlib to make visuals. And then after there are advanced libraries like TensorFlow, which is used for neural networks, and which is made by Google. So it's also open source. So there are different libraries. That is why people tend to use Python, because you don't need to create something else. It's already done for you. You just need to use those functions and you will get the results, right? You just need to play around with that. And also we need to import this stats model, because our EDF it's going to be used these libraries. So it's import stat models dot just let me have a look, because I have already done it before. Stats model.ts, because sometimes I don't remember the exact how to integrate the library, so I can just copy it. If you got any question, you can feel free to ask any question you got, because I know because some of you might have not done this Python. So if you got any question, you can directly ask me, because I am also learning it. So yeah, we are on the same page. So for example, I have done this code, right? So for particular this model, I will just run over here, or you can just press Control Enter, right? And we got error. Which error? No modules got matplotlib. Okay. Oh, it's matplotlib, right? So we get error, and we also get module not found. No module name matplot. And we can also get we can also search on Stack Overflow what people are saying about this error. So from that you can also learn, right? And if like you can see this green tick, so you can get to know that our library is imported, right? Now what we need to do is we need to upload our CSV file, right? So what we do is Amazon underscore data. This is how we call variable. For example, what is variable? If for example I will just show you, this is variable name Amazon data, and I put number 3. So I have put number 3 value in Amazon data. So whenever I need number 3 or any kind of information, that I just need to call this variable. I'll just show you. For example, if I print Amazon data, right, it will give me number 3. So this variable is for reuse. Like if we just need to define this variable once, and we can use it anywhere in our code, right? So for example, in Amazon data, we will do pd.readCSV. ReadCSV is a function of Pandas, which is useful to read or upload any, because we have already uploaded our file, right? We just need to use that file in this particular code. So what we need to do is we just need to put our path. So we will copy the path of this Amazon data CSV, and we will in single quote we will put our path. So it's in the content and then / Amazon data CSV. When we run it, so yep, then we get to know, okay, it's done. Now we have to look at what our actual data set looks like, right? So what we can do is it's because all our data is in now Amazon underscore data, right? So we just need to Amazon underscore data. If we do dot head, now we will get to know this is our date, this is open, high, low, close, adjective close, I don't remember the column, adjusted close, yeah, and volume, right? So now what we need is we only need close, because we are going to do the forecasting for close, right? So in particular, because we are only looking stationarity element in particular column, right? Because if I will just show you how the close variable is looking like. So Amazon underscore data, if you wanna call particular, if you wanna fetch particular column name, you can do Amazon data, and in the large bracket we can see this close, right? And if we run this one, then we can get to know that what is close column looks like. Sorry, this one is already there. See, now we just need to print this one.
Yep.
I can directly print on this one. So print function is very basic. Like if you get any kind of error, just print it. What kind of variable is showing, what kind of data it is showing. So we will basically get the idea. So see, this is all the columns from 0 to 249, and the length is 250, and data type is float 64. It will only also give you a data type, that what kind of data type is there for particular column name. You can also change the data type as we do in like Tableau. We change the data type to date, month or year. There are also already all the functions. So you just need to change the data type if you wish. But in our case, we don't need to do it. And we can also see that what our data set is looking like. So Amazon underscore data, and we wanted to look at the close, how the close is looking like. So but the thing is, we have to put the actual column name, like close, the C is capital in the close column name. So we just need to put close, otherwise it won't give you the result, right? Because the column name should be perfect. Dot plot. So this plot function is from Matplotlib. So now we get to know this is our close column and this is our data. So you can see there is little bit a downward trend. So we cannot say that whether it is stationarity or not. So what we can do is we can directly run a stationarity model, like stat models dot add fuller is the function. We can, because we have already imported the stats model, we can do result. We can put a variable result is equal to add fuller is the function name, and we can do Amazon underscore data, and the column name is close, right? So what we get in result, let's see, we already got our result, we just need to print the result, right? If you get any question, just feel free to ask me, because yeah. So this is what we get as a result when we run this add fuller test, right? So this is our ADF test, and this minus 1.279 is our test statistics. I will also put the, because in any ADF test there is a null hypothesis and alternative hypothesis, right? So in our case, always null hypothesis is, because we already know this statistics, right? We already done the statistics. So HO is the data set is non-stationary. Data set is non-stationary, right? Sorry, my writing,
fine.
because
That's fine.
and we can also do HA or H1, whatever you want to call, right? And it is, the H1 is stationarity. Stationarity element is there in our data set, right? You all got this concept, right? So for example, and our significance level alpha is going to be 0.05, which is pretty much used by all of the people to find whether data is stationarity or not. So in this one, if our probability p value is less than 0.05, then we can say our data is stationarity in there in our data set. And if it is greater than 0.05, then we can say our data set is non-stationarity. That is non-stationary, right? Sorry about that. Right. So in this one, we can get to know this first parameter is test statistics, and the second one is 0.63. It's our p value. So our p value is greater. It's greater than 0.05. So we can say that this is not a stationarity data set, right? So now we can also convert this particular column in different with a diff function. So it will give you better results about the particular data set. So to do that, we can run diff result is equal to diff dot, what was the variable name? Sorry about that.
So the diff is the differencing technique
Yep.
that you use to convert it into.
Differentiated values.
Yep.
So for example, we will only use this to convert particular close this Amazon time series data, or we can say, because we have another data set, Amazon underscore data, but our column is close. So we just need to only convert this particular column into this differentiated value. For example, now we will also print this different underscore ts. So we'll get to know what kind of results we are getting. So it has converted into a differentiate level. So it will convert particularly in fluctuation. Now if we have a look at this plot, now we'll have a look that how does it look in the line chart, right? Dot plot. And we can there are also other parameters, like in particular plot function there are different parameters like x-axis, what kind of x-axis you wanna put, what kind of title you wanna put, what kind of color you wanna choose. So there are lots of different parameters in this particular function, so you can use those. For example, if you wanna use title, so we can say title is equal to differentiated value, right? And we can run this.
Underscore ts.
Oh yeah, sorry. So it's ts. The plot. Now we get to know. So this is our converted differentiated column, closed column. So this is how it differentiated. Now we can run our ADF test to look at the p-value. That what is the p-value, right? So we will also learn. We will also run again the add Fuller test. The final result is equal to this one. Add Fuller is our function name, and what the data is like different underscore ts, and we can also print this result, that what this result says, final underscore result, right? See, now our test statistics is minus 15.88 and our p value is 8.69, but there is a minus 29, so it's very less than 0.05. So now we can say that this data is stationarity, that is stationary, and there is stationarity element in this data set. So this is how we can convert this value in Python. And if you guys got any question in Python, you can ask me in regards with this particular test.
Actually, I have a question.
Yes, sure.
I'm not so sure if you have gone through, but I wonder, like, for example, when you scroll it up a bit
Yeah,
on the screen, like the stationary about the like closing one for this chart, is
Mhm.
that we need to go through every step as above so that we can mark,
Yeah.
generate before, like if either we're missing any of the above queries, then we cannot generate that.
Yeah, for example, if you're directly running this one, right, Amazon data of the closed particular column. So, but how can this script runs? Because there is already Amazon data variable in the in this its memory. But if you don't run this one and you directly run this one, so it will give you error that Amazon underscore data is not defined, right?
Okay.
So you just need to, yeah, sure.
It doesn't exist.
Yeah, it doesn't exist ultimately if you don't run this one, right?
Okay.
If I delete this one, and because I think it's already in there, what I will do is I will show you a new one, for example.
So is it kind of similar to those like 42,000 SQL one that we need to like import, and once we kind of make the queries, it's stored it?
Yep.
Then even though like you just like you demonstrate like delete it, it's still there?
Yep. So how compiler work is like, for example, we have first imported all the libraries. If we directly run the pd.read CSV, it won't get, because we haven't imported the pandas library. So how it will get to know that it is a function of pandas? So you will have to run. For example, if I close this project and I again run this, so it won't give me the last result, or it won't give me any result. I need to run it from the front, like from the first. First I will run this one, second I will run this one, and then this one, and all this in the sequence.
Got it, thank
Yeah,
you.
no worries, that's all. Yep. I will do R afterwards because she wanted to explain us regarding feedback.
Yeah.
Yep, you can go ahead.
Are you sure?
Yeah, sure.
Come on in. Thank you.